And we are back.
Hi, after we talk about conversational AI, we'll talk about more about application for NLP. So that's first, I will start with a video clip about Baymax, personal healthcare companion.
It's a different kind of hurt.
You are my patient. I would like to help.
You can't fix this one, buddy. What are you doing?
I am downloading a database on personal loss. Database downloaded. Treatments include contact with friends and loved ones. I am contacting them now.
No, I don't do
Your
that.
friends have been contacted.
Unbelievable. Now what are you doing?
Other treatments include compassion and physical reassurance.
I'm okay, really.
You will be all right. There.
Thanks, Baymax.
Okay, after this video, I think you will know that in the beginning of this video, because this main character's brother died, and the Baymax don't know how to treat this sadness problem, so they just try to find some document online, and they just extract the information. They find there are two treatments, and the first one is to contact friends, and the second one is to give a hug to this person. So you can imagine, if we have very good natural language processing technique, we can try to make the machine to understand medical document and try to assist both doctor and also patient. So for example, currently, because of coronavirus, so there are so many clinical information or like a medical document about the report, or like a paper publication about medical scenario, and you can treat as a lot of passage, and you can build a QA system and try to allow the machine to read a lot of text, and also you can ask a natural language and try to get the answer. So for this example, this is a machine comprehension task, just like QA. You will give a passage and also the query. The query is just like a question, and this machine should be able to find the answer based on the passage. And in the medical domain, this is the product from Baidu. Baidu AI produced a medical assistant. Based on the conversational scenario, you can ask the patient's symptom and try to understand the semantic behind the sentence, and also try to ask the follow-up question. For example, the corresponding symptom or some possible disease you may have, and give you the suggestions. So based on the conversational scenario and also belong to medical domain, you can have a lot of application about intelligent systems. And I want to share some recent work from our research group. The first one is clinical note understanding. For example, in the hospital, usually the doctor will have take a note about the patient. For example, this is the diagnostic test, and usually based on this note, in hospital, usually there's a job called coder. Need to label this text into a corresponding diagnostic code. For example, some code may belong to some symptom, some code may belong to some disease, and based on the sentence, like a clinical note, you need to label the corresponding code. For example, this note contains two corresponding codes, like fever and also some disease, I'm not sure. And this is called multi-label classification problem, because usually classification is based on the sentence, like passage. You make the final classification and you design a single label. But this task, it is a multi-label problem, because you need to consider multiple potential code for this scenario. And in the medical domain, it's very complex because, for example, ICD is a worldwide general code schema for medical code, and they have like maybe more than thousands of codes need to be considered. So definitely, if you need to consider that many codes in a single node, it's a very difficult problem. And also, the table is very imbalanced. What do I mean by imbalanced? Some code appear very, very frequently because some symptom is very frequent in appearing in different disease. And some, for example, some cancer, this disease is very rare. So some code will happen very frequent, but a lot of code are very rare. So this is very weird distribution. And definitely you know that if we have a code which appear frequently, and it means our model will have more data about this code. So we will have better performance to predict for the certain code. But for some rare code, it means we do not have a lot of data. That means definitely we cannot get a very good performance. So this is a very difficult problem because usually machine learning approach can only handle the frequent code, but cannot handle the rare code. However, if you want to use this system in a real world, you definitely need to allow the machine can handle both scenarios, the frequent code and also the rare code. But the rare code, usually they do not have a lot of data, but how to get a better performance for the rare code. So we try to utilize some expert knowledge. For example, in the ICD schema, they have the code information. For example, two codes may belong to the same category. For example, there's two codes, they belong to personality disorder. So we know they are related to each other. So sometimes in the basic model, if you predict this code or this code independently, they do not share any information about each other. But if you have the information about this hierarchy, then you know, all of these three codes belong to the same category. So you can explicitly ask the model to share some information about each other. And for example, this code, if they only have a small set of data, but they can also get the benefit from the code from these two codes if they have more data. So this idea is very flexible. They can integrate with any model architecture. And also they can address the data imbalance issue because the data, if they have the frequent code, it means more data, they will have better performance. But for the rare code, they have less data and they have poor performance. But to the rare data, they can share the information from the large data. So this is the example from our experiment. Based on this clinical node, although it's very complicated and you don't need to understand it. And the baseline is the previous system, okay? The red means the correct one. Ground truth is the correct. They have a lot of code. And the proposed model is the improved version of the baseline. And the red one is the same as the previous baseline, but you will have the blue one, which is additional correct one. And why we will have this additional correct one? Because we know this code may belong to another, may have the correlation to another code. So they will increase the probability to have another similar code. So they will increase the chance to get the correct labels. And for the doctor perspective, they definitely want your system to produce more code and they can filter out compared to you just produce less code, but there are something missing. So this is one application we work on. And another medical application is medical document understanding. Previous is medical clinical note. And for medical document, definitely we can try to understand it as well. So the special type of the publication, which is called RCT report, which is published by PubMed, which is the archive in the medical domain. And randomized control trial is an experiment frequently applied in the hospital. For example, you have a whole group of the users, like the trial, and you just separate into two groups. And one group, you just, for example, you give them a certain drugs, and another one is you do not give them the certain drug. And you want to see the difference between these two groups, and you want to check whether this drug has the positive effect to the scenario. Okay, so usually after this experiment, they will have the report about this experiment, the RCT report. And RCT report will have the background and objective, like why we want to implement this experiment, and the result, what's the finding. There's a difference between these two groups, or there's no any difference. It's a positive effect or negative effect. And they have the conclusion. So this is a structured, like well-structured report. So we want to utilize this structure and to see whether the machine can understand it correctly. And what did we do? First of all, this is the source. This is a document. They have the background about the experiment. They have the result, okay? And they will have the conclusion. Like the conclusion has this result. For example, this drug is positive effect or negative effect. And for this one, it's negative, okay? Then we want to allow our model based on the source and try to directly generate the conclusion. Just based on the report, we only give them the objective and the result, and they will automatically generate the conclusion and tell us whether this drug is positive or negative, or there's no any difference. Want to directly generate this natural language in the conclusion. And we'll show two examples in our result. The first one, okay, this is the source. This is the original target, which is the conclusion written by the original author. Okay, so this is the perfect one. So these two are the generated one. So the first version, we generate the goal is the positive effect, but we generate, oh, it's a negative effect. Okay, if you work on some medical domain, I hope you can understand, but I guess probably most of people cannot understand it, including me. Okay, and the next one is we give them additional word, hint word, like we tell the model the first word should be the, and they will generate the correct answer. Like they say, oh, this intervention is positive. Okay, so they will automatically generate suitable conclusion. And for the next example, we will all generate the positive and also the same as the original conclusion. Okay, after we talked about the medical domain, next one I want to share some news domain. It's also my recent work. It's a iLander, which is an interface we want to monitor the news media channel, because we find this is a good quote. Misinformation is not like a plumbing problem we fix. It is a social condition like crime that we must consistently monitor and adjust to, because this scenario will happen because different scenario. So we want to have a good system to consistently monitor and try to teach our citizens to adjust to this scenario and to know what information is incorrect or misleading, and they will automatically filter this misinformation by their own. So we want to provide a platform. Islander try to utilize the AI like NLP technique to empower readers to understand the news delivered and also the news they receive, and also to understand the media intention behind the news. So just like want to estimate the news quality, want to analyze this news has the good quality or the bad quality. Because we find there are three important problems in news media. First one is bias, and the second one is hearsay, and third one is sedition. So we want to check three indicators in order to design the truthworthiness for each news article. Like this news article is neutral or not, is credible or not, and objective or not. How to measure these three indicators? If we can measure these three indicators, we can estimate the truthworthiness based on a function. And based on the news article, we will give them a score. Then we can aggregate the score for each media, and we will assign which media may be more truthworthy and which one is not very trustworthy. But how can we measure each indicator for news? It's very different from like medical domain because we need to design three indicators. The first one, we want to estimate whether this news article is neutral or not. So we want to consider the standpoint of this original news article. So how to detect the standpoint? First, we do the news clustering, and we will detail the information about this procedure. After we do the clustering, we will summarize the event we extract and analyze the stand. So there are so many news every day, and you know that different media channels, sometimes they will produce the news article based on the same event. So definitely they will have very similar distribution because they mention same words, but probably from different angles. So based on the clustering, we can cluster the news into, for example, we have 5 different groups, and each group indicates a certain event, and there are so many news articles mentioning this event. And after we get the event, then we know, for example, the first event, the group 1 and group 2 is the second event, the group 3 is the third event, but we only know we have, like, for example, 9 different articles belonging to the first event, but we don't know the topic. So the second one is we need to summarize the event. What is the event of this group? So we need to extract some keyword. For example, the first one is about some recent news from Taiwan. It's military and fleet information. And the group 2 is also very similar to the first one, but it focuses more on the coronavirus scenario. And we will extract the keyword for different news, for different events. So you will see, oh, we have 3 different events, but they have multiple articles talking about the same event. And the last procedure is we need to design, based on each news article, what is the standpoint for each behind the news. So based on this topic, probably these 3 articles describe this event in different angles. We need to decide, oh, this is a positive angle or a negative angle. What's the standpoint point for each news article. So then we can measure whether this news article is neutral or not, because usually journalists should not have any personal standpoint. They need to talk about this event, just not mentioning any personal opinion. And the second one is about credibility. Credibility means if you have this news, you definitely need to have the source information. You cannot directly say something without the source. So based on this news article, we can analyze this news article by detecting the source entity, because the source entity is a person, and the source content is the information this person said. So we can utilize the NLP approach to extract the entity and design the source. And probably we can collaborate with the fact-checking company or fact-checking organization, and they can check whether this source really convey this content or not. And after we can decide the credibility, the last one is whether this article contains a lot of sensation information. So we need to do the sentiment analysis. For example, based on a news article, sometimes if they use a lot of, for example, the subjective words and emotional words, it's not suitable for a news article. Also, because sometimes they contain too much sensation information and may mislead the readers. For example, disappointing or like surprising, we can detect whether this word have the higher arousal or the higher valence based on their word information, because every word we can estimate their sentiment. Sentiment will have two dimensions, like a valence and also arousal. We want to design this information and try to aggregate the sentiment information for each word in a whole document and design the level of sensation of this document, and to check the final objectivity of this document. After we get the trustworthiness of each news article, we can aggregate the news article information for each media and journalist, and we can have a leaderboard to monitor its daily ranking, and probably want to promote the better media or better journalists, and try to allow the bad news media to not generate too much misunderstanding, misinformation for our readers. Okay. It's just like to have a platform to provide this evidence so that the reader can know whether this article or this media is good or not. Just like to consistently monitor and automatically aggregate this information. Okay, so this is the example from the news domain. And after we talk about the different application about NLP, and finally want to move to the summary and challenge, and we will go to the QA session afterwards. To summarize today's talk, first of all, the human-machine interface is a very hot topic, but you will notice that there are so many components need to be well integrated. So if one component may produce poor result, they will influence in the next component, and finally you will have very poor performance for the system. And a lot of techniques are based on deep learning, and the good thing is we will have a lot of available framework or available model online. We can download the model, we can download the framework and run in your own data. But you need to prepare your data, and you need to collect your data you need to annotate your data. Usually, you require a large set of the label data to have better performance. And an important issue is to do the domain adaptation with scarce data. Because sometimes if you want to move to the second domain, you don't want to do the old things to get again. You just want to do additional things, and you can directly move your model to the second domain. So how to reuse the previous rules or previous knowledge is very important. And currently, everyone knows that handling, reasoning, and personalization are very important. But these days, we do not see a lot of customized product because of privacy issue. But you know, if we can have a lot of your personal information, we definitely can have better interaction with your own scenario. So this is a difficult balance between the privacy and the personalization. And data collection and analysis is very important because you need to analyze your data first, and you will know how to collect the good data. If you have a good data, probably in your first version of system, you will have very good system, and you can improve it continuously and more easily. And last one is, this complicated cascade system usually require very high accuracy for each component, because usually if you want to have a good performance in the user side, you want to have the high accuracy for each component. Otherwise, based on the multiple interaction, if the one component performs poorly, then the final performance will be degraded. And last one, I want to share another movie to you. This is called Her. It's not as famous as Iron Man, but I hope some of you may already watch this movie before. And if you didn't, I just summarize the information about this movie. This movie is this character, they just fall in love with his intelligent assistant. It's a cloud service. Because this cloud service really understands this person a lot and are very empathetic, and so this man just feel there's no real human can understand me. You are the only one, so they just fall in love with this intelligent assistant. But the ending of this movie is a little bit, I'm not sure how to say that, just surprised me a lot. The ending of this movie is this man just find this service, this intelligent system, they can simultaneously talk to a lot of men. So he just feel very angry. So afterwards, he feel heartbreaking. So this is the end of this movie. So after this movie, it will make me think about what machine can achieve right now and also in the future. How can we make the balance between the real human or just like a machine? The machine can only help you, but not very empathetic. Otherwise, probably you may fall in love with the machine. So this is a very interesting scenario to share with you.
Okay, and I think now it's time for our real-time Q&A. Are there any students who have questions and want to call in to ask Vivian? Okay, I see that previously there was a student whose ID is POLL at 1970. I think you called in but canceled. Do you want to call in again? I'll give you 3 seconds. Okay, if not, then let's check out some of the questions that other students have given us. For example, the first one, is accent a bit of a problem in NLP, Vivian?
Yes, Actually, ASM make the problem for the first component, which is the speech recognition, because as I mentioned, if you cannot recognize the speech into the correct words, then the following component may have poor performance. So if you ASM may degrade the performance of the speech recognition. So this is a very important problem. And some solution is you can train your data using the certain ASM. They will have better performance to the certain ASM, but definitely it's a little bit difficult to handle different type of ASM. So you need to consider to be more general, or you need to customize into different person. And or probably another solution is you can make the following component, like NLP part, try to consider the potential error for the previous component just based on their sound. For example, they recognize into the word A, and the word A may have very similar sound to the word B, and probably you will also increase the probability for the word B, and to make the change of the original recognized result and try to mitigate the gap.
Okay, so the second question is very similar. How can different speech accent be achieved? So it's just like what you explained?
Yes, I think so.
Okay. And the third question, empathy speech, can empathy speech be learned by AI?
Yes, like recently I saw the paper which trying to work on the empathy part, and they also they learn this scenario based on a data set, which is the empathy data set, and they have a question and also the answer, and they also have the specific empathy for for example, if you say I'm sad, and you may have different type of response are reasonable, but probably only two are more empathy than others. So they will have this score. So they will try to learn which one is more empathetic to the system and try to generate more empathetic response to your input. But it definitely depends on the data you collect, because the empathy is very vague. It's a concept, and there's no very, it's a subjective information. So different person may have different definition about empathy. So it's also very difficult to do the evaluation.
Yeah, sometimes even people can't
Yes.
recognize your emotions,
Yes.
right? Okay, next question. What is the difference between NLP and knowledge graph?
Oh, actually, NLP is more focused on the natural language part, like how to decompose the natural language or how to extract the information about natural language. And the knowledge graph is like a symbolic information. You can imagine it's like a lot of semantic items. So a lot of NLP tasks, it just want to make the connection between natural language to the knowledge graph. Because knowledge graph, you already define, oh, this is the person, and this is the, maybe the person's job, the person's location, the person's something, and you want to make the sentence, mapping the sentence information to the specific knowledge item. Like this is the, for example, the sentence is, I live in Taipei. So I is the person, and Taipei is the location. So the person and their location and the age between these two nodes, this structured information belongs to knowledge graph. So linked understanding is very similar to connect the natural language to the knowledge graph.
Okay, I hope this answers your question. Our next question is, NLP has developed for a long time, but the change is not too much. There hasn't been much change for a couple of years. What's the major obstacle?
Oh, I see. Actually, compared to, for example, to computer vision or speech processing, like NLP, the progress is relatively slow, and the major difference is NLP is the discrete information. For example, I love you, we have 3 words. And these 3 words are discrete, right? But if you have the speech, I love you, you have a speech signal which is continuous features. And if you have an image is also a continuous feature. So the deep learning approach is more good at this continuous feature. It's not very good at the discrete feature, because the discrete feature, you need to design how to make this discrete feature as a vector to input your model. So I think this is a major gap between the discrete and continuous scenario. But recent, like 2 years ago, NLP part get a large progress these days. So there are more and more application and also improve a lot based on the recent proposed model. So I think you will see more advanced approach and also the progress for the NLP field.
Okay, and last question. The basic TF-IDF and LSTM and BERT are they different methods? How to choose between the different methods?
Oh, I see. TF-IDF is a traditional way to do to represent the sentence or like the document. And it's based on the statistic concept. And it's very simple. And sometimes the performance is also good because they usually don't need to collect a lot of data. And the second one is like LSTM. It's an onion type approach. And it's a type of deep learning approach. But this approach, sometimes you need to have the corresponding data set to train your model. So the TF-IDF may be more suitable to the initial stage. Like if you do not have a lot of data and you just want to do a quick survey, you can use the first one. And if you collect a certain amount of data, you can use the second part. And BERT is the more advanced version. It's also, it's just I mentioned like 2 years ago, because of BERT, so that we will see a lot of progress in NLP just based on this model. And this also based on deep learning, but it also needs to have the corresponding annotation, and you can train your model. So I think the second one and the BERT, the LSTM and BERT, you can try both. And sometimes you may not have large difference between these two, and sometimes you may have the difference between these two. Depends on the task.
Mm-hmm. So this will be the end of our Q&A. I think Vivian still has another video clip she wants to share.
Yes, and I want to share a very interesting video, which is a product from Japan, and I think it's very cool product. And after this video, in this video you will see this intelligent assistant. The function is relatively simple, but they can achieve a lot of things.
朝ですよ。起きてください。ねえ、起きてってば。おはよう。
おはよう。
あ、今日雨が降るかもしれないから傘持って行って。急がないと遅刻しちゃうよ。
They can tell the weather information.
行ってきます。
いってらっしゃい。気をつけてね。
19ページ、商品のラインナップについての。
ああ、家で誰かが待ってるっていいもんだな。さっき思ったんだ、帰ってくるとき。おやすみ。
おやすみなさい。
You may notice that this avatar can open a lamp and also maybe open a air conditioner for this person. And definitely the functions are really simple, but after watching this video, they will make me think this is just like a virtual girlfriend, and whether this person will make the real human girlfriend or not, or they just stick to this virtual one. Is this good or not? Or sometimes another opinion will say, because this person don't want to get a girlfriend, so they will have better life if they have this product. So they just come up with a lot of controversial issues, debates about this topic, whether we want to allow this machine to stay as a human or just a machine. So this is a very cool issue and controversial scenario for you to discuss.
Something for you to think about today after class. Well, thanks again to our wonderful speaker today, Dr. Yunong Chen, Vivian, and thank you all for joining us today. If you have any questions, just leave us a message. And if you want to follow Vivian's research, she will provide her Instagram or and YouTube. Yeah, and also this.
This is my contact information. If you have any question, you can email to me, and also provide my IG. There's no professional information in my IG. But my YouTube, I just upload like my research talk or like my lecture, but it's in Chinese. So you can also follow my YouTube channel.
Okay, our next class will be on Saturday. Don't forget to join us. Anyway, good night, and we'll see you again. Good night. Bye.